This video is part 3 of a review of integrating quotients. If you haven't seen parts 1 and 2, see the links in the description. The title of the 6th set of problems warns us that we will be completing the square as we go along. However, I don't think we will need to complete the square in part A. I see that the degree of the numerator is 1 and the degree of the denominator is 2. The denominator wins by exactly 1, which tells us that we will need to do u substitution. Let's let u equal the entire denominator. So that'll be x plus 3 squared plus 16. In that case, u prime will equal 2 times x plus 3. And that's it. I was looking for the chain rule, but we would just be multiplying by 1. So that's u prime. Let's go ahead and do the u substitution. As we do it, I'm going to rewrite the numerator as 7 times x plus 3, just factoring out that 7. So I have this over u, but instead of dx, we write du over u prime, which is 2 times x plus 3. But then we notice that we have x plus 3 in the numerator and in the denominator. So those cancel each other out. The 7 over 2 can come out in the front of the integral like this. So we really have 7 over 2 times the integral of 1 over u du. This is a memorized rule. The integral of 1 over u is the natural log of the absolute value of u plus c. Don't forget about the 7 over 2 out in the front. Substituting x plus 3 squared plus 16 back in for u gives us the final answer. For part B, the degree of the denominator wins by 2. That tells us to use an inverse trig rule. We can already see that we have x plus 3 squared. So that means that u will equal x plus 3. In that case, u prime is simply going to be 1. And we can see that the a value will be 4 because the a value is the square root of this constant. Doing the u substitution gives us this. Normally, I would say du over u prime, but u prime is just 1, so there you go. This is a perfect match for the arc tangent rule. So let's go ahead and integrate. We need to do 1 over a. A is 4, so we will have 1 over 4. And then arc tangent of u over a. So that's going to be x plus 3 over 4. So that's it. I noticed that we still didn't have to complete the square. Maybe on the next problem. I see what's happening, yeah. This time, we don't have parentheses squared given to us. So we will have to generate those parentheses squared by completing the square. So let's begin. So we will have x squared plus 6x. Leave a space right here before you write your plus 25, because this is where we will complete the square. To figure out the special number that completes the square, I always say the phrase in my head, half the middle squared. The middle is 6. Half the middle is 6 divided by 2, and then I'll be squaring this. And that will tell me what goes in the third number of the trinomial. 6 divided by 2 is 3. 3 squared is 9. So that tells me to put a 9 right here. The problem is I have changed the value of this expression by adding a 9 to it. So I must immediately subtract 9 to cancel that out. This way I've really just added 0, so I've changed nothing. So that's it. We completed the square, but why did I do it? The point of this is that if we choose this third number just right, it will always factor, the trinomial will always factor as the same binomial twice. X squared is x times x. 9 is 3 times 3. I see this as a positive 6, so these will both be positive. X plus 3 times x plus 3 is the same as x plus 3 squared. So let's write it that way instead. Okay, x plus 3 squared. 25 minus 9 is 16, so this will be plus 16. This expression is equivalent to this denominator. So let's rewrite the original integral, replacing the trinomial with this new expression. This integral matches the arctangent rule, where the u value is x plus 3, which means that u prime is just 1, and the a value is 4, the square root of 16. Let's go ahead and do that substitution. Normally I would say let's replace dx with du over u prime, but u prime is just 1. So there you go. Now we can use the arctangent rule to integrate. We see 1 over a, so that's going to be 1 over 4. And then we have arctangent of u over a. But u is x plus 3, so we will have x plus 3 over 4. And this, my friends, is the final answer. We won't have to complete the square for part D because they already gave us x plus 3 squared. Also, I don't think we need an inverse trig rule this time because the degree of the denominator wins by exactly 1. That tells us to do u substitution right away. Let's try letting u equal the entire radical, so 16 minus x plus 3 squared. And I guess we'll see what happens. In this case, u prime will equal negative 2 times x plus 3. And that's it. So let's go ahead and do this u substitution. As we do it, let's factor out the 7. So we have 7 times x plus 3. And then we have the square root of u. And instead of writing dx, we will write du over u prime, which is negative 2 times x plus 3. This is looking promising, because the x plus 3 in the numerator will cancel out the x plus 3 in the denominator. The 7 over negative 2 can come out in the front of the integral as negative 7 over 2. So then we have 1 over the square root of u du. But 1 over the square root of u is the same as u to the negative 1/2 power. So let's use the power rule of integration. Adding 1 to this exponent gives us positive 1/2. Then we divide by the new power. Dividing by 1/2 is the same as multiplying by 2. Constant of integration. And we still have the negative 7 over 2 in the front. So we multiply by negative 7 over 2. We notice that the 2 in the denominator will cancel out this 2. So we end up with negative 7 u to the 1/2 power plus c. But what was u again? 16 minus x plus 3 squared. Let's go ahead and rewrite this with a square root instead of a 1/2 power. So there's your final answer. Part E. I noticed that the degree of the denominator is 2. The degree of the numerator is 0. So the denominator wins by 2, which means inverse trig rules. But this trinomial looks nothing like any inverse trig rule. To make it look more like the rules, we need to complete the square for the trinomial. Let's get started. Negative x squared minus 6x plus 7. Right away, I don't like having this negative as my leading coefficient. So I'm going to take that outside of some brackets. So that will leave x squared plus 6x. Let's go ahead and leave the gap now and say minus 7 after this nice space in it. I'm going to leave a little extra space before I put down my bracket. So it is time to complete the square. I think the phrase half the middle squared as I try to decide what the magical number is that will complete the square. I need to do half of the middle, so that means I'm taking this 6 and I'm dividing by 2. But then it is half the middle squared. So 6 divided by 2 is 3. 3 squared is 9. So that is the number that completes the square. So I put a 9 right here. But as I add the 9, I have changed the value of this expression. I need to balance it out with a minus 9 on the end. So I've really added 0 and I have changed nothing. By picking this third term just right, we guarantee that when we factor this trinomial, it will always factor as the same binomial twice. In this case, it will be x plus 3 times x plus 3. But let's write this as x plus 3 squared instead. So we have x plus 3 squared, and then negative 7 minus 9 is negative 16. And all of that is inside of some brackets where we have this negative sign out front. I don't want to leave it like this, so I can distribute the negative sign, which will give me negative x plus 3 squared plus 16. And then I can easily reverse the order of these. So I can write this as 16 minus x plus 3 squared. So this trinomial under the radical has the same value. It's equivalent to this expression right here. So let's rewrite the original integral with this expression instead of the trinomial. So now we have this. Notice that this matches the arc secant rule if u is x plus 3, which means that u prime is just 1, and we have an a value of 4. The a value will always be the square root of the constant. So let's go ahead and make that substitution. So we will have the integral of 1 over the square root of 16 minus u squared. Instead of dx, we will write du over u prime. Well, u prime is 1, so forget I said that. We will just have du. This is now a perfect match for the arc secant rule. Notice that the arc secant rule has no 1 over a in the front of it. So as we use this rule to integrate, we go straight into arc secant. Arc secant of u over a. So in this case, that will be x plus 3 over 4. And then constant of integration. So there you go. Luckily, this is the last problem because this video is getting a little bit long. I can see that we will need to complete the square on this trinomial, so let's jump into it. We have the x squared plus 6x. Leave that space. Half the middle squared, half of 6 is 3. And then if you square it, you get 9. So I'm going to put that 9, and then I need to balance out the 9 with a negative 9. This trinomial right here will factor as x plus 3 times x plus 3. Ha, pretend that's a 3. But we will write this as x plus 3 squared. And then negative 7 and negative 9 make negative 16. So this expression is equivalent to this trinomial. We will rewrite the integral using our new expression. So we have 1 over x plus 3, and then the square root of x plus 3 squared minus 16 dx. We notice that this integral matches the arc secant rule very nicely if u equals x plus 3, which means that u prime will equal 1, and also a will equal 4, because a is always the square root of this constant. If we do that substitution, we get the integral of 1 over u times the square root of u squared minus 16. Instead of dx, we write du over u prime, but u prime is 1, so that's just du. Now this is a perfect match for the arc secant rule. So let's use this rule to integrate. We see that we have 1 over a, which in this case will be 1 over 4. And then arc secant of the absolute value of u over a. This is the only rule that has an absolute value, so don't forget it. U over a, in this case, is x plus 3 over 4. And constant of integration. Kabam! We're done.